Dear students, welcome to another lecture in Industrial Engineering Quality Control. Yesterday, we started this new chapter on quality control and inspection. Yesterday, we saw the quality, the definitions of the quality specifications, and quality characteristics. So, continuing with from yesterday, let us see what is quality control. Now, quality control is defined as an effective system for integrating the quality development, quality maintenance, and quality improvement efforts of various departments in an organization so that production and services at the most economical levels which allow full customer satisfaction, so that we can achieve these things. That is the definition. See, what is the definition saying? It is a system, and that is an effective system which integrates, or which can say combines, these things, these three things. What is that? Quality development, quality maintenance, and quality improvement efforts of various departments in the company. In an organization means a company or an institution or anything, so as to enable production and services at most economical levels, and which guarantee the customer satisfaction. So all the efforts of various departments which are contributing to enhancing the quality of a product, so those things can be called as quality control. This is one definition. Another definition is, it can be defined as the tools, devices, or skills through which quality activities are carried out. There can be some instruments, some gauges, some measuring instruments, and other things. There can be devices, there can be skills of the employees through which the quality activities are carried out. Okay, so this is one definition of quality control. This is another one. Okay, by means of quality control, we can measure and compare the actual quality performance with the specified standards, so that necessary action can be taken in case of any deviations from the standards. Now there is a standard specifications according to some national standard, or company standard, or customer standard, or whatever, a standard, like this we want to make, we want to fabricate, or we want to machine. But how close we are able to come? See, we are measuring what? We are measuring and comparing actual performance with the specified standards, with the standards. See, if these two are not matching, then we have to take some necessary actions. So how we are measuring those things, how we are comparing those things, that all comes under quality control. Okay, now let us see the objectives of quality control. Why do we have to do quality control? What is the need for it? Okay, see, first one is improved income. Improved income means all the people who are involved with that company, or with that institution, or you can say all the stakeholders, their income salary that comes every month into their houses, that should increase, that should improve. To improve company's income by making the product more acceptable to customers. If the company's income increases, then the people's income also will increase. Okay, it is like that. So now why are we doing quality control? So that the improved income will come. So if the quality is good, the income will, the people will buy, more people will buy your product, and the more people you buy, the more income you make. Then cost of reduction to reduce companies production cost by improving the quality of products, by products being being manufactured, which obviously reduce the number of non-defective products and scrap, and therefore the loss is reduced. See why we do the quality control? So that quality of the products being manufactured is improving. So if quality is improving, rejects will reduce or defective items will reduce. Okay, and thereby scrap reduces, wastage of material reduces, thereby the cost reduces. That means for less amount of money you are able to make the product, but your MRP or the maximum retail price will remain the same. That means if the cost reduces, you will make more profit. Okay, then the third objective is interchangeability. You see, if you control the quality, you will be able to achieve interchangeability in mass production. Otherwise, your specifications may be so different that you to use interchangeability, it will be difficult. Then customer satisfaction. This is the main goal, of all our efforts. Customer should be satisfied. To ensure satisfaction of customer by manufacturing products of high quality level, thereby minimizing the number of consumer complaints regarding replacement of the defective product received or poor performance of the product causing trouble to operate. You see why a customer complains? Because some defect is there in the product when he got. That is one thing. Otherwise he may complain also because it is not doing proper work. Its performance is poor. So if he complains, see, next time he won't buy your company's product. He will look for better products in the market. So if the customer is not satisfied, you will be losing the customer. You're losing the customer means he's not going to buy your product, and you're going to lose your market share. Your competitor will gain, you will lose. So customer should be satisfied. Okay, then next objective is optimum quality. Optimum quality is producing the good quality or acceptable quality products at the minimum price. You see, when you say optimum, there is a compromise. There is a compromise. See, if you want to produce the best thing and you spend a lot of money for that, and nobody is willing to shell out so much money, then what is the use? You see, it should be the money that is there in the pocket of the user or the consumer, should be able to buy your product. Okay, that means what? You produce optimum quality things which he is willing to spend money for. Then integration of quality effects. You see, integration means combining, you can say, to integrate quality development, quality maintenance, and quality improvement efforts of various departments. Various departments will be working towards the quality. Quality development, one department may be looking after. The quality maintenance, another department may be looking after, and the quality improvement, third department may be looking after. If you want to integrate all these activities and see that everybody is working together, then you have to have something called as quality control. So this is another objective. And another objective is quality mindedness. So to create quality mindedness among the workers. See, if this quality mindedness, if everybody is minded to maintain good quality, you see, everything, all the products that they produce, all the processes they adopt, and all the housekeeping and all the maintenance, everything, will be of a higher standard, have higher quality, and they will begin to like their premises, their products, their company. They'll be able to boast about their company to others. This quality mindedness should be inculcated in the minds of the people. Okay, next is quality of design. You see, quality of design means it is concerned with the tightness of specifications for a manufacturing product. As a mechanical engineer, we will be able to appreciate what is the tightness of specifications. You see, suppose you want to produce a shaft of diameter 50 mm. But exactly 50 mm we cannot produce, so we specify some tolerances, like upper limit and lower limit. We'll say 50 plus or minus 1 mm, or 50 plus or minus 2 mm. 1 mm 2 mm will be too large a specification, too large limits. So instead, no, they'll have 50 plus or minus 0.2 or 0.05 mm, like that. They will specify. You see, the more closer, the more tight they are, the better quality. Okay, so now this quality of design, when we say, this is concerned with this tightness of the specifications of the product. So quality of design is defined as the quality specified by the design engineer on behalf of the customer. The customer, he has given his feedback. He has revealed what is in his mind, how the product should be, what all it should perform. He has told. Okay, so keeping that in mind, the design engineer fixes the specifications. So the quality specified by the design engineer on behalf of the customer is the quality of design. And that means what? Though the design engineer is specifying the limits, it is actually the customer who is specifying the limits. Okay, it's like that. A design specified by very tight and closed tolerances to basic size of the component to be manufactured is said to have higher quality of design than a design specified by wide or loose tolerances. Now let us see, for example, a part to be manufactured with a drawing tolerance of plus or minus 0.001. Okay, this will be considered to have better quality of design than a part which is having drawing tolerance of only plus or minus 0.01. See, this is 1,000th of a millimeter. This is only 100th of a millimeter. Okay, so therefore such a tolerance is a very close tolerance. This is a broader tolerance. These are closer tolerance. Therefore, if you say which is the better quality, the close tolerances ones are better quality. Generally, greater the requirement for strength, fatigue resistance, life of the product, function and interchangeability of the product. If the greater is the requirement, then it is the better quality of design. See, the customer is wanting, greater strength, greater fatigue resistance, greater life, greater function, greater interchangeability, everything, more he wants. That means what? He is willing to shell out more money. Okay, that means, he wants a better product. So that means in his mind, he is having that, my thing, money is not the criteria. My thing is, the quality of the product should be good. Okay, see, that is the thing. if everything now greater in a requirement of strength, fatigue resistance, life, function, interchangeability, etc., for other such as the characteristics also, if you're talking about, then that means what? It is the quality of design is better. That's what we can conclude. Needless to say that design should be simplest and least costly without any compromise in customers' requirements. But at the same time, now with all these requirements of strength, fatigue resistance, life, interchangeability, etc., with all these things, if two companies are producing and both are of meeting his requirements, then he will choose the less costly one. Okay, just because you are meeting his needs, you cannot demand any amount of money. Okay, some money also plays a role here. Okay, because that is where when the competition is there, you have to be careful. The customer should not go leave your company and go to the competitor. Okay, next, now let us see about the factors governing or controlling the quality of design. See, here some 4 factors are given. Now, types of customers in the market. See, what type of people? Is it the common person is buying? Is it that poor people are buying? Is it that middle class people are buying, or is it high class people are buying, or is it the governments who are buying? Who is it that companies who are buying? You see, depending upon that, which type of customer he is, depending upon that, this quality of design will be governed. Okay, then intended life. That means how many days, how many months, how many years it should last. Then what are the environmental conditions where it should be working? What is the reliability that you are expecting for the product? Then what is the improvement in the continuity of service? If you are providing them service and continued service, how you improve, depending upon all those things, the quality of design depends. The controlling of the quality of design is governed. Then specific requirements such as strength, fatigue resistance, life, interchangeability of manufactured products. Upon this also it will depend. If he wants good fatigue resistance for his product, then you have to choose material which is good, which has good fatigue resistance. You have to look at the property of the material. If that material is itself, the raw material itself is costly, then he has to shell out more money. Okay, so fatigue resistance and all these things, these specifications are fixed on the basis of these requirements: strength requirements, fatigue resistance, life, interchangeability, etc. Then economic considerations with profit to company. Then this is always there, economic consideration. And at the same time, company should make profit. It cannot simply be doing social service. That if you're doing social service and if you're not caring for the profits, then very soon you'll go bankrupt. Your company will close. Okay, then next is quality of conformance. Let us see. Now first we have seen what is quality of design. Now let us see what is quality of conformance. Now quality of conformance is concerned with how well the manufactured product conforms to the quality of design. Now quality of design is, we said it is regarding the specifications which the design engineer decides on the behalf of the customer. Okay, once those specifications are fixed, then the company has produced the product. Now how this manufactured product is matching with the specifications set by the designer. If it is matching, that means it is very closely matching, then we'll say the quality of conformance is very high. Otherwise, we'll say, the deviations, or if the deviations are much, we will say that the quality of conformance is poor. Conforming to others means not matching with something like that. Quality of conformance is an important area of quality control, where most of the sampling methods, statistical techniques, you don't worry at this time what is sampling method, what is statistical techniques and other things. We are going to study these things in detail. Okay, where most of the sampling methods, statistical techniques have been experimented and used to analyze the quality of the manufactured components or parts. So this is an important area. Quality of conformance is an important area of the quality control. See how close we are coming to the quality of design. Okay, when a consumer purchases a product from the market and starts to operate it, then the performance of the product depends upon these two things: quality of design and quality of conformance. On these two things that we have seen just now, it depends. See, one thing is quality of design, first we have seen. Now quality of conformance we have seen. Now factors governing or controlling the quality of conformance. See, quality of conformance, you have said the quality good, but you could not. Quality of design is very stringent, but quality of conformance is poor. Why it is poor? Why we could not achieve? Because of some factors, like your raw material is not good. If the raw material is good, you will be able to get a high quality of conformance. If the raw material is poor quality, okay, then you may not get the high quality, you will get low quality of conformance. Similarly, how good your machines are. If your machines can maintain close tolerances, then your quality of conformance will be good. So it depends upon all these things. It depends upon the raw materials quality, it depends upon the machines quality, it depends on the tools quality, it depends upon the measuring instruments quality and other things. It may even depend upon the workers also, the labor, okay, etc. should be capable of producing finished products having adequate standards. In addition, they should be maintained properly. Okay, so this is one thing on which the quality of conformance is depending. Second thing is appropriate process selection and adequate process control. See, the process selection as an industrial engineer, what he is selecting and how the process he is controlling. Depending upon this also, this is in the purview of the industrial engineer. Okay, then how trained and experienced the operators are. Okay, then effective inspection program, whether you are having inspection program in the first place, and even if you are having the inspection program, is it effective? So just some people will have just for namesake some inspection program, but that inspection program doesn't find anything, doesn't reject anything. Everything, if it accepts, even the defects will be accepted. Defects should not be accepted. It is question of the reputation of the company. Okay, then another factor is feedbacks of internal inspection as well as customers should be analyzed for taking corrective action. This also, whatever the inspectors are giving feedback and the customers are giving feedback, these also should be analyzed, and not only analyzed, you have to take corrective action. Okay, you see, when you are serious about it, you will take feedback from the concerned people, and also you will analyze the feedback, and once you analyzed and you have found out this is the problem, you will take corrective action also. See, so many people just to please somebody, to please their higher ups, they'll be filling the papers, filling the forms, not seriously doing these things. If such people are working, then you cannot expect good quality in that company. Then proper care should be taken in transportation, shipment and storage of finished goods and products. Why? Because in the transportation also and in the storage also, your goods can be damaged. They can, or if they can be exposed to harsh environments, and some chemical reactions may take place. The things may get rusted, all those things. So that is why when it comes to the customer's hand, you will say, I asked something and these people produced something else, and what is the design, the quality of design, and what is the quality of conformance, these two are not matching. The quality of conformance, that means, is poor. He will conclude like that. So you have to take care till it reaches into the hands of the end user. Not only that, he has to even when he is using also, it should last long. Okay, then only if it is a good quality thing, you will it will last. Okay, now the third one that we are saying is quality of performance. Now till now, we have seen how quality of design and quality of conformance. Now quality of performance. Performance means, the name itself says how it performs. How it performs. We have ordered for a bicycle, and how is it, when you are cycling it? Okay, if you say, oh, it is fantastic, that means no, the quality of performance is good. The quality of performance is it is concerned with how well the manufactured product gives its performance, how well it is doing. It deals with the total performance of the product. Now, factors governing the quality of performance. Now, what are the factors? Factors governing the quality of performance are two. One is quality of design and another is quality of conformance. These first two things that we have seen. Even if the quality of design is best and the product, but the product can give poor performance. Why? Because you are not produced properly. Okay, that means your quality of conformance is poor. You have not stuck to the specifications. Okay, your specifications are not close enough. Close enough, the design engineer has fixed, but you have not produced according to those close standards. Therefore, it didn't conform to the design of quality of design. Okay, now similarly, if quality of conformance is best, the finished product may not perform well because the quality of design specified before the actual manufacturing is not correct. You see, the other way also. You see, one is quality of design was good, quality of performance was poor. Then also customer is unsatisfied. The other way is quality of performance is good, but the quality of design was not set properly. So even then the customer is not happy about it. Okay, so how well it performs, it depends upon these two things. So therefore we conclude that best possible quality of design and good quality of conformance together will ensure excellent quality of performance. So these all three are going. If these two are good, the third will be good. That is the meaning. If quality of performance of a product is not good, then what happens? Then it leads to increase in number of complaints. If he is not happy with the bicycle that he has got, he will complain. The customer will complain. Okay, increase in customer complaints for replacement within the specified warranty period against the defective or damaged product. Then you have to take back the defective thing or the damaged thing, and you have to give them a new one. Okay, is it going to help the company to make profits? In such cases, no. In case increase in number of service calls for customers for repairing and servicing the product. If the quality of performance is poor, then it badly affects the reputation of the company. And if reputation is bad, then what happens? If the reputation is bad, then what happens is the customer won't buy. So that means what? Sales volume of the product will drastically fall. Okay. Thus, a continuing feedback system is necessary for providing quality information to act as a basis for decision making regarding the optimization of quality of product. So that's why feedback is important nowadays. Online shopping, everything you're doing, you're giving 3-star, 4-star, 5-star rating, or 1-star, 2-star, whatever you give. That feedback is so important to improve the quality. If the quality can be improved, that means you are keeping the customers happy. If the customers are happy, you will have business for many more days to come. Okay, now let us see something called as reliability. Actually, this is a big topic, reliability. Actually, when I was studying MTech, we had a whole subject on reliability. Okay, now we are studying as a small topic in quality control. Okay, what is reliability? Reliability is defined as the probability of a product. Now statistics has come into picture here. When you say probability, statistics has come into picture. Okay, the probability of a product that it will give satisfactory performance over sufficient time period. So what is the probability that the motorcycle you are buying will be performing well for 10 years? uh, if the probability is more, if it is, if I'm 80% sure probability is there, 90% probability is there, that means what? So much is the reliability on that. Okay, so this is the probability of a product that it will give satisfactory performance over sufficient time period. Then another definition is the probability of a product functioning in the intended manner over its intended life. Suppose a machine, a motorcycle's life is 15 years. Is it 15 years? That's what government says. You register your motorcycle, car, or all the equipment for 15 years. You insure them for 50 years. You register them for 15 years. Afterwards, we won't encourage you to register. Even if you want to register and run those vehicles on the road, we will charge you exorbitant money, because they will contribute to pollution, and they will be detrimental to the environment. That's what they say. So all the machinery they have only 15 years of life. That's what. Okay, did you ever register a vehicle for more than 15 years? Did you ever insure a vehicle for more than 15 years? The brand new one is registered only for 15 years. It is insured for 15 years. Okay, maximum, that is the maximum. But in very rare cases, no, they will register for another 5 years. But nowadays the government has increased the registration rate so much, so it is not worth registering. Okay, you just throw away that vehicle and buy a new one. That's how we should. But in India, we are not so accustomed to throwing away, isn't it? Anyway, reliability means the probability of a product functioning in the intended manner over its intended life. If the intended life is 15 years, how it performs, does it perform as you wanted it to perform for the whole 15 years? If it performs, no. If you are thinking, I'm 100% sure that for 15 years nothing happens for this, that means your reliability is 100%. That is the probability. Okay, like that it is. In simple words, reliability is the capability of the product not to break down when it is being used. For that, some mathematical equations and other things are there. but at this stage we need not be going into mathematics. But anyway, there is one formula here how reliability is given. Reliability R suffix T is equal to e raised to the power minus lambda T, where RT is the reliability over life T. This is the life, number of years is T, where R is the reliability, RT is the reliability, and lambda is the failure rate, that is number of failures per unit time. Okay, that is the reciprocal of lambda is called as mean life or mean time between failures. Mean time between failures. Suppose if you have if you are a company owner and in your company you have installed 1,000 lights. Let it be any incandescent lamps or CFLs or LED lamps or whatever lamps. See, 1,000 things you have installed, but is it that all the 1,000 will be of good? Everything will be good and nothing goes off. You will see. Within a few days, one or two here, one or two there. They are not burning. They have failed. You see, and all those things are noted. And then they will find out this something called as mean time between failure. What is the average time between the failures? Okay, that is the reciprocal of lambda. Anyway, don't worry about the mathematics here, because you won't be asked numerical questions on this. Okay, when you study in depth, either at bachelor's level or master's level, then you can study it in more depth. Okay, various number of components are suitably assembled to create a product. In a product there will normally there will be many parts there, many components there. Therefore, reliability of the product depends upon the functioning of each component. Like we said before, the quality of an assembly depends upon each of the components. Similarly, reliability also depends upon each of those components. For example, if we purchase an electric lamp which may light properly at the time of purchase but may burn out after 200 hours of use, then it is not said to be reliable. Suppose the company is promising that you purchase our lights, our electric lamp, it will work for 1,000 hours. If it works 1,000 hours and you are saying it failed in 200 hours. 200 hours is not a big deal. 200 hours means what? You see, 1 hour has 24. One day has 24 hours. So for 4 days you are clocking 100 hours. For 8 days, 200 hours means in 8 days continuous use, it is fused. It is not working. It is failed. That means it is not so reliable. Okay, whenever a consumer purchases a product, then it is expected that the product should give satisfactory performance over a long period of time. Who will be happy? He's selling out so much money and it failed in 1 day, 2 days. Now who will like it? Even the rich people won't like it. Even if they have plenty of money in their banks, they won't like it that the product is failing. They will come and fight. Okay, hence it is important that a product should function and continue to function satisfactorily for a reasonable time period. Okay, then next is difference between quality control and reliability. You see, now quality control means consistency of the product, and that affects the reliability. You see, quality control maintains consistency of the product, maintains the quality of the product, and if the quality of the product is very high, then the reliability also will be high. Like that it is. Quality control is entirely a separate function which is concerned with a small period required for manufacturing the product. Quality, you see, we are not talking only of quality, we are talking about quality control. Quality control is of various things that you are doing, till it is manufactured. That's all. Okay. And what goes out, so when the product goes out, it has quality. Okay, only with it, not quality control. Quality control is only within the company. As long as it is the company what you are doing, only those activities, those tools, those skills, those things are quality control. Okay. And quality, we give the product and send it to the customer. Okay, so quality control is entirely a function, a separate function, which is concerned with this for a small period of time, uh, till it is manufactured, whereas reliability is concerned with a long period of time, through the life of the product. Okay, then factors to be considered for achieving excellent reliability. If you want to excellent reliability, it's a reliable product. If you want to say, what factors you should consider: protection against external parameters. Parts and components of a product should be protected from extreme temperatures, pressures, vibrations, etc. Okay, see, that care should be taken when in the hands of the user or the consumer. Okay, next is maintainability. Product should be easily maintainable. In case consumers call regarding improper functioning of the product, service engineer can visit the customer's place and repair it in minimum period of time. See, for small light bulbs, they may not go and give service, but for bigger machines, equipment, they will give service also. Even for our cars, motorcycles, they give service. Okay, see, if the service, if you give within time, if it is, you can maintain a maintainability, if it has maintainability, then you can achieve excellent reliability. Okay, if it is running without oil and you don't bother, you don't put oil, how do you expect it to have good reliability? It won't. Okay, simple designing. See, the simplicity of design, if the things are complicated, in the complex world of all the parts, something may malfunction. Okay, so it is better to keep simple design. And then serviceability. Product should be easily serviceable. Sometimes the products are produced in such a way that you cannot reach some product to oil it, to grease it, or to do anything to it, or to replace it. You cannot reach. That means it is not serviceable. It is very difficult. Some of the things cannot be opened. So, see, that means it is not serviceable. Serviceability should be done. Nowadays, in the olden mobile phones, we were able to take the batteries and everything in the hand. Nowadays, they pack in such a way that we cannot take the batteries, we cannot open anything. Means you have to go to the service center. Thereby, they are ensuring that their service centers are also always with the customers, and they are selling the product and doing the servicing of the product. Okay, serviceability. Anyway, safety. Extremely safe during operation also should be there, for excellent reliability. Okay, friends, I think today we'll stop here, and we will continue in the next lecture. Thank you.